All right, today we're going to tackle the derivatives of 6 trig functions. So I'm not going to do a formal proof of where they come from. You might just have to take my word for it, but I can show you a quick visual example on where some of them are coming from. So I've got 2 functions graphed here. The blue one, notice it starts at 1 and it looks like sine or cosine, but it starts at its max. So I'm going to identify this as y equals the cosine of x. And the red one starts at 0 there, and it looks like the sine curve. I'm going to identify that as y equals the sine of x. Okay, so remember, this whole course is about the word slope, which is another word for derivative or rate. So if we want to visually look at the slopes of these graphs, I'm going to start with the sine function. And I'm going to pick some slopes that are obvious to me, that hopefully will be obvious to you at some point. And I'm going to go ahead and put a point. So focus on the red graph, and in your notebook, put a nice point there. And then we're going to draw a tangent line at that point. Remember, that tangent line just kind of kisses the graph on the cheek once there, and it just kind of balances there. So we love flat lines. If you're a skier, you probably don't like flat lines unless you're a cross-country skier, if I'm saying that correctly. This line has a flat slope, which we would like to say has a slope of 0. So and let's just put an m equals 0 here. So we're identifying that the slope is 0. So if I wanted to graph its derivative, and that's my point here, I'm going to graph the derivative of sine. I'm going to go ahead and I'm going to plot the point 0. So kind of ignore the blue graph for a moment. All right, I'm going to go to another, on the red graph, still on my sine graph, I'm going to find another point that I really like, and I'm going to draw a tangent line there. And there again, we have a nice flat slope. Okay, it's not going up or down, so it's a flat slope. And I'm going to say that slope is 0. So I'm going to go right to the function. I'm going to put a 0 there. And let's see, I think there's another one here. A nice flat slope of 0. And another one here, a nice flat slope of 0. So I'm going to plot those 0 points. Now, interesting that it's ending up on that blue curve. I'm going to pick a few more points here. I'm going to say all of these slopes are, draw some tangent lines. Would you agree all those slopes are positive? Now, I would say it's probably the steepest right about here. And then they kind of get less steep. They're kind of getting closer to 0, right? They're getting less steep. So it's going to be the highest that it is about here. And then again, these are getting less steep. They're getting closer to 0. And I can do the same thing looking at my blue graph. These are getting, I'm looking at the wrong graph. Going back to the red graph here. These are getting steeper, 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 probably the steepest. And then they get less steep as they go up. So it's going to be high here. And if I were to plot more of these points, you would find out that when I graph the derivative of sine, I actually get cosine. Pretty amazing. Not a formal proof, but again, looking at it visually. So one thing I want you to jot down right away, d dx, where if we derive the sine of x, we actually end up with the cosine of x. All right, let's take a look at a second graph. So looking at the 2 graphs again, we still have sine and cosine. So my red graph is the y equals sine of x. My blue graph is y equals cosine of x. All right, so I'm going to focus on the blue graph now. So try to ignore the red graph. Probably should have made that a little lighter. I'm going to find a nice flat point because I love flat slopes. Right here on my blue graph, I'm going to draw a dot in my tangent line. And I'm going to say, okay, that has a slope of 0. So I would plot 0. Interesting. I'm going to go to this one here. I'm going to say, again, it has a slope of 0. That's my tangent line. Oh, look how it's ending up on that red one. Okay, I'm going to go blue here. This has a slope of 0. Blue here. This has a slope of 0. Now, let's not just assume anything. Let's kind of calculate some more here. Let's take a look at these slopes. I'm going to put some tangent lines on my blue graph, on my cosine graph here. What do you know about these slopes? Positive or negative? Okay, obviously we're going to read left to right. These slopes are going up. They are positive. And I would say it's the steepest, again, probably around here, and then it gets less steep. So I would say this probably has a slope close to 1. Wait a minute, that didn't end up on my red graph. Interesting. Okay, so that has a slope close to 1. I'm going to go on to this side of the blue graph. These slopes are all negative. So that means it's going to be below the x-axis. And again, probably the steepest here. So I'm going to say that's a close to -1. Again, these guys have positive slopes. Probably the steepest here, so probably close to +1. So take a notice, I'm not actually getting the sine graph. I'm getting something close to it. It's still going through the origin. It looks like sine, but instead of going high first, it's going low first. So what we can say is the derivative of cosine of x isn't actually sine, but negative sine of x. Okay, because it ends up going low first. So again, these aren't formal proofs, just kind of a visual way. We do a lot of graphing derivatives throughout the year. So I just kind of wanted to touch base on that. What you do need to know are these 6 trig functions and their derivatives. So we talked about trig during our first week there, and now we're back into trig. So I'll just kind of give you the rundown on how I do it. I like to memorize things in pairs because I think some of them look alike. And in fact, you can jot that down in your notebook, and then I'm going to put my pairs together, which I think are important to go together. So I'm just going to box in the first two, because we just talked about the derivative of sine is cos, and the derivative of cos is negative sine. And I always memorize those two together. So if you can get any of the trig derivatives down before school starts, let's aim for these two. Okay, we'll talk about these again in class, but let's aim for those first two to have those memorized. Now, I don't memorize the rest of them in the order that they have them here, because I think two things are similar. I try to do tangent and cotangent together. So I'm going to write them down and talk about why I do them together. And I'm going to rewrite them slightly different. The derivative of tangent, notice where they put their squared. We don't typically write it there. We call it secant squared of x. And the derivative of cotangent is negative cosecant. And again, I'm going to move the squared in, squared of x. And let me just jot the other two down how I would write them. I would do the secant and cosecant together. And again, this is how I'm memorizing them. Secant x tan x. And the derivative of cosecant x is negative cosecant x cotangent x. All right, and make some notes for yourself. And again, I'm trying to give you the tricks and tips that I use to memorize these pairs. So I'm going to go to this group here. Both of these kind of have tangent in it, tangent and cotangent. So the two functions with tangent both have one term squared. And that's kind of my trick of memorizing it. They both have one term squared. The other thing that I say to myself is anybody that has co in it also has a co in its derivative. Cotangent, cosecant. Okay, the co's go together. So make little notes for yourself. In this section, I memorize these two together because they start with themselves, like they repeat themselves, and then they multiply by a trig function. It repeats itself and then multiplies by a trig function. And notice the co rule applies here. Cosecant has all the co's. Cosecant, cotangent. Those c's all go together. Now, another super important rule that you'll notice is if your trig function starts with a c, and again, write it out how you need to in your notebook, its derivative is negative. So if your function starts with a c, its derivative is negative. Take a look. Cosine is a negative sine. Cosecant, negative. Cotangent, negative. So anything that starts with a c does have a negative derivative. So at the end of the day, you really just have to memorize these trig functions. Flashcards are great, whatever it takes. But like I said, try to at least get these first two down before the bridge starts, before school starts. Okay, so let's just have at it. We'll practice some questions. So keep your cheat sheet of all your trig derivatives. Number 1, we want the derivative of -4 sine. Let's just talk about being good readers of math. When you see these parentheses here, can I highlight here? All right, verbally, you want to say the word of. So this is read the -4 sine of x, okay, plus 9x. Let's just make sure we read things correctly. So it's fairly simple. This is not a product rule because there's not an x attached to this. It's just a coefficient, so it just stays. So I'm going to leave it as -4. The derivative of sine, we just said, is cosine of x. And the derivative of 9x, remember that's linear, so it's just plus 9. And that's it. You have your derivative. So they're really not super difficult. You just kind of have to memorize them. Number 2, f of x equals 5x cubed minus 6 cosine of x. So again, read it out loud to yourself because you're going to do a lot of communicating this year, a lot of talking out loud. So let's just make sure we read it correctly. So let's find f prime of x. So this is just a simple power rule. We bring that power down in front. So I've got my 15, subtract my 1, so x squared. All right, minus 6 is a coefficient. And the derivative of cosine, notice how I put parentheses in because we're multiplying, is negative sine of x. It starts with a c, so we know it's negative. Now, the reason I want parentheses here is because I want to show the greater. I'm not subtracting, I'm actually multiplying those. So I have 15x squared, negative 6 times negative sine makes that a positive 6 sine x. Okay, so what seems like annoying simple things, you do have to make sure that you're replacing things with parentheses. That is key. Number 3. We want the derivative of 3 cosine of x plus 4x squared. All right, so the 3 is a coefficient, it stays. The derivative of cosine is negative sine. Notice again, I'm using parentheses, plus just a power rule. Hopefully you're saying in your head 8x. And then I'll just, again, multiply, clean it up. You don't want to leave a minus sign in the middle. All minus and plus sign should come to the front of a function. So this is going to be 3 times negative, technically a 1. So that's negative 3 sine of x plus 8x. All right, now number 4. Here's where it's going to get goofy. And again, this reading out loud is a big deal. When I read this, and you always want to read it like you're reading to an elementary student, this doesn't say x cos of x. This says g of x equals x times the cosine of x. Okay, notice how when I read it out loud, I said the word times. When you hear that word times in your head, you need to be thinking product rule. Okay, it is a product. There is an x in the front, first term, and there is an x in the second term. So I do have to catch product rule, and reading out loud is the easiest way to do this. It sounds silly, but literally during every test, you hear people kind of talking out loud to themselves. It's really important that you say things out loud. So let's go ahead and derive g of x. G of x becomes g prime of x. And let's talk out that product rule we did the other day. The product rule is the first derivative of the second plus the second derivative of the first. Okay, so I'm going to go, my first term is just x, and notice how I'm substituting with parentheses, times the derivative of the second. So the derivative of cosine, it starts with a c, so we know it's negative, negative sine of x, plus the second, which is cosine of x, times the derivative of the first. The derivative of x, which is linear, is just 1, because obviously there's a 1 in front of there. And then again, clean it up. We don't want to leave negatives in the middle of a problem. So x times negative sine x becomes negative x sine x plus cosine of x times 1 is the cosine of x. And that would be our final answer. Okay, so remember, go back, pause, and rewind when you need to. These are always here for you. 5. The derivative of x cubed, so again, read it out loud like you're reading to a young student, x cubed times the sine of x. So again, I'm going to rewrite it, x cubed times the sine of x. So I'm going to say my first term before my times has an x, and my term after my times has an x. So why don't you pause it, try the product rule, and then we'll compare. All right, so I've got my first term. The derivative of sine is just the cosine of x plus sine of x times the power rule here, 3x squared. And again, I'm just going to pull coefficients in front. So I'm just going to leave this as x cubed, the cosine of x. But here, I would pull this term in front, 3x squared times the sine of x. Is it wrong? No. It just won't be written that way as a multiple choice. And if you have a coefficient, you do want to properly pull that in front. All right, so trig is coming back, obviously, and we really got to make sure we know our trig value. So again, I would say this is something else that you really need to know cold before coming back to school. We should know our trig values. So we're going to do them in degrees and radians. 30 degrees is equivalent to pi over, remember pi is 180, 180 divided by 30, or picture 18 divided by 3 is 6, pi over 6. 60, I know I do these out of order. Again, I'm picturing 180 divided by 60. That goes in there 3 times, so that's pi over 3. They kind of flip-flop. The 3 goes with the 6, the 6 goes with the 3. And then 45 would be pi over, and again, this one I always think is easy, just common sense. Well, it's not writing. How many 45s in 180? Well, remember, if these are 290, there's 1, 2, 3, 4. Oops, 1, 2, 3. 1, 2, 3, 4 45s and 180. So the sine of 30, or pi over 6, is 1/2, as well as the cosine of 60. The sine of 60 is radical 3 over 2, as well as the cosine of 30. We said the tangent of 30 has all the 3's. Then it loses the denominator. Sine and cosine of 45 are both radical 2 over 2. And the tangent of 45 is 1. All right, we've got to make sure we know these. And you'll see why in just a moment. So I'm probably going to make your brain hurt for the time being, but just go with it. Take a break when you need to. Pause it. Come back. Do what you need to do. So this is question 6. What is the value of the derivative of cosecant of x at pi over 6? So if you need to pull up your cheat sheet of the derivatives because we don't have them memorized, that's perfectly fine. So look back in your notes. The derivative of cosecant of x. Well, we know it starts with a negative because it starts with a c. Cosecant repeats itself. Cosecant of x, and it's a co, so it has the other co in it. Cotangent of x. Now I have to carefully plug in pi over 6. All right, so let's plug in our pi over 6. Okay, now these are all the reciprocal trig functions, so we do have to remember who they came from. So, cosecant, again, was the reciprocal of sine. Cotangent was the reciprocal of tangent. So we did a lot of this in Algebra 2. So I really want to think of the sine of pi over 6, which again is 30. So in your this is what I'm thinking now. Thinking what's the sine of 30. So go back to your trig values. The sine of 30, or you should know it, is 1/2. And because I really want cosecant, I flip that upside down. So I'm going to get 2 here. And I have that negative out front. Now I need the cotangent, whose reciprocal is tangent. So I'm really going to think the tangent of 30, because that's pi over 6. Tangent of 30 has all the 3's. So that's radical 3 over 3. But I want cotangent, so that's 3 over radical 3. I'm going to put this over 1. So I would say I get negative 6 over radical 3. Now, we typically don't leave radicals in the denominator, so if it is a choice, we're good to go. If they rationalize it, remember you just multiply by that top and bottom of the radical, so I get negative 6 radical 3 all over 3, and then those two can divide, so negative 2 radical 3. So both of those are correct, just if it's multiple choice, you just got to figure out which one matches. All right, let's try 7. What is the derivative of cotangent of x at 5 pi over 6? All right, so cotangent starts with a c, so we know it's negative. The tangents both have something squared, tangent and cotangent. And because it's a co, it also has a co. So this is cosecant squared of x. So now I have to plug in my 5 pi over 6. So negative cosecant squared of 5 pi over 6. Whew, okay. Now watch how I rewrite this one. I want to square the answer, so I'm going to really say it's negative. Now this squared is only on the cosecant. It is not on the negative. So I'm going to leave the negative out front, and I'm going to use a nice big bracket to say I want the cosecant of 5 pi over 6, and I want all of that squared. So I'm just moving the squared from here to out here to say take that answer and then square it. All right, so cosecant, again, goes with the trig function of sine. So I really want to think to myself the sine of 5 pi over 6 and flip and square that. So the pi over 6 tells me I'm looking for the sine of 30. And we know the sine of 30 is 1/2. Now this 5 tells me what quadrant it's in. If I have 5 times 30, that gets me a 150, which is in the second quadrant. And remember, all students tip cows. Sine is positive. So this 5 just tells me whether I'm positive or negative. So this is a positive 1/2. I have to square it. And the negative's out front. So if I square the 1, I get a 1. If I square the 2, I get a 4. And then because I actually wanted cosecant, I have to flip that upside down. So I get a -4. So again, the reason I'm flipping my answer is the question was really cosecant. I just had to flip my sine answer to get it. Number 8, we want the tangent of x at x equals pi. So tangent, remember tangent and cotangent are one term squared. It doesn't start with a c, so we know it's positive. The derivative of tangent is secant squared. And I want to plug in my pi, so secant squared of pi. And I'm going to rewrite it because we don't like where that squared is. So it's the secant of pi and all of that squared. All right, so now I need the secant of pi. Well, secant goes with cosine. Okay, secant of x goes with cosine of x. Some people just kind of flip those letters around, the c and the s, to help them remember secant goes with cosine. All right, so I really want the cosine of pi squared, and then I'll flip that. All right, so let's picture the cosine graph, because pi is on the graph, right? Pi over 2, pi, 3 pi over 2, 2 pi, etc. So cosine starts at its max, then it hits 0, and then it hits its min. So the cosine of pi is -1, and if I square that, I get 1. And if I flip 1, 1 is just 1 over 1, I still get 1. So I would say its derivative is just 1. Number 9, the secant of x at h prime of 0. So h prime of x, okay, secant doesn't start with a c, so it's positive. And it repeats itself and puts somebody else. So secant, if you look back, is secant x tangent x. And now we need h prime of 0. So I need the secant of 0 times the tangent of 0. Okay. Now, I'm going to start with tangent of 0 and watch for the reason why. When I picture the tangent of 0, I'm picturing the graph. So I'm going to go to tangent, and if you remember tangent, so here's my pi over 2, my pi, 3 pi over 2, etc. Tangent does the opposite things. It starts at 0, and then it has an asymptote. Then it goes back to 0, and it has an asymptote. Goes up on the right. It kind of increases the whole way. Okay, so notice the tangent of 0 is 0. Which is wonderful. I don't even need to waste my time here because the tangent of 0 is 0, and 0 times who cares is always going to give me 0. So if you know one of them 0, it kind of makes your life a lot easier. You don't actually have to evaluate the other function. If I wanted secant of 0, just to be clear, I'd be thinking secant goes with cosine. So I'd want the cosine of 0, and if I picture my cosine graph, the cosine of 0 is 1. And if I flip 1, I still get 1. And 1 times 0 is still 0. Let's try one more here. Cotangent of x. All right, so g prime of x, it starts with a c, so we know it's negative. The derivative of cotangent, tangent is the one term squared, is negative cosecant squared of x. So now I want g prime of pi over 4. I've got negative cosecant squared of pi over 4. And again, I'm going to rewrite this because that's not written correctly with the squared. So I want the cosecant of pi over 4 squared. Okay, and again, the negative stays outside. All right, so cosecant, that big S in the middle, tells me I want to think of the sine of pi over 4. So the sine of 45. Sine of 45 is radical 2 over 2, and then I have to square it. So the square and the square root cancel, so that's a 2, and the denominator squared becomes a 4. And 2 over 4 is equivalent to 1/2, so I have negative 1/2. But that is the sign. I want cosecant, so I have to flip it. So I would say my final answer is negative 2. Okay, so don't forget to flip when you're all done. All right, I'll give you one to practice here on your own. So why don't you pause it, try to talk yourself through it, and then I'll talk you through it in a minute. All right, so I took my derivative, negative cosecant cotangent, substituted in my pi over 3, and then I said, okay, where did they really come from? Again, cosecant goes with sine, cotangent goes with tangent. So now I need the tangents of pi over 3, which again is 60 because 180 divided by 3 is 6, or 18 divided by 3. So I'm thinking 60. The sine of 60 is radical 3 over 2. The tangent of 60 is just radical 3. When I multiply, I'm picturing that over 1. So radical 3 times radical 3 is 3. 2 times 1 is 2, and I have the negative in front. And then because that wasn't the real question, that's what I changed it into, I need the reciprocal, so I'm just going to flip that upside down. So I've got myself a negative 2/3. Well, I think that gives us plenty of practice, and I'm sorry if I made your head hurt with all the trig, but we use quite a bit of trig throughout the year, so we'll just keep coming back to it. We'll have some practice for you.